Hi, Savoy. Hi, Tees. Tees? Right. Numbers are coming up. As you come in, please. Hi, Ari. Hi. Yes, I got you, Savoy. All right. Writing down people who are there. Let's see. So, live stream. We have Savoy's here. Ari's here. Tees is here. Billy's here. Okay, that's four as far as I could. Okay. Liz is here. Okay. Mila did say hi. Okay. And not that this should be the plan, but just I will always don't know how often we'll do this, but every time we do this, I will post a video of the live stream. So if you do miss it, say you're sick, for example, or your computer doesn't work at that time, you can always do it later. Hi, Haley, and just so you know, just because I don't know, can one person maybe post this right now, a reminder into your WhatsApp chat, seventh grade, 7F, 7Fs to say, hi, don't forget, YouTube, yo, right now, Blessman, P. Blessman. P. Blessman is the handle. Howdy. We all did already. You did it already. Okay, Finn's here. Good. That's good. Okay. All right. Okay. All right. Savoy, you do that. We all did already. Okay, Mila says she doesn't see it. Okay, so Mila needs to go to P. Blessman or Phil Blessman on YouTube, and she should be able to click on it from there because it's listed as a live stream that's active. So that should work, Savoy. So Don is trying to get in, but it's not working. Okay, refresh will be a good tip. That's good. So Don, working on it. Mila's working on it. Okay, let's see about the other ones. Any news about Jan, Kian, Charlotte, Keanu, Noel, Colin, or Neela? Any information about any of those people? Because we still have a few people absent, but we'll get started shortly, not to make you guys hang out and wait forever, just because some people can't get in. Mila is here, but can't comment. Oh, she's here. So she's physically with you? Okay. All right. Hi, Charlotte. Oh, here's Mila. Good. Okay. Good. Mila is also here. Okay, good. Jan, Kian, Keanu, Noel, Colin, and Mila. Oh, Pro Jello is the down. Okay, cool. All right, we're pretty close now to having most people here. And as mentioned, maybe some other people come online in a second. And otherwise, you can always look at this later. So this is my first day doing this. You guys are my fifth class. So okay, so if you guys can limit comments to things that are related to the actual class, that would be awesome. Yes, I love all of you too, and you guys are missing each other. I get it. It's funner to hang out together at school than sit at home alone. Oh, this is, by the way, my first part. So before we start with the physics, I just want to encourage you to realize, and maybe you're already at that point, this being day 5 of no school, that even though initially you might have been thinking, yeah, Corona vacation, um, I think you probably realize by now that that's not the case. This is not a good thing for many reasons, not just because people are going to get very sick. For you educationally, this is difficult because realistically, whatever school time you miss, you will not learn as much as you would have if you'd been in school. And that's not good. So you have to kind of think about how you're going to make sure you still learn and then get smarter and all those things and go to university and get jobs and all that, because it's important to have skills to be able to do that. So okay, so Voice put it pretty clearly there, as well as hey, we got to figure this out. Also, here's the mindset you should have. I do not know how long this is going to take. They say right now April 20th is the plan to be back in school. Most people probably feel that we are probably going to take longer than that. Okay, thank you. Neela's here as well. We are probably going to take longer than that, maybe even till summer vacation. Hi Colin, I do not have any inside information, but in your mind, think about the possibility. What if we're not having any more school till summer? That means you really need to worry about how are you going to build the skills that you would have built in over half a semester of school in all your subjects: physics, biology, mathematics, English, German, history, and everything else. Okay? So get out of the mindset of vacation. Also get out of the mindset of, oh, this is just hard to fill my time, to I need to figure out how I can be the best student I can be in this time. Okay? Good. Now, back to what we're doing. So the last thing we did was we did a lab on density. And I believe I did not yet give you a due date because I think we weren't done with. Thank you, Savoy. I'm glad it's been changed. I do not think I gave you a deadline to turn in said lab report because we were going to talk about how to do it specifically and finish that conversation. And then our class got canceled. Is that correct? Penny Schultz. Is Penny Schultz Billy? And why is he logging in with something else? Oh, okay. I think that's true. Okay, good. Well, not good, but let's just kind of talk about what you need to do for that then. Okay, yes, yeah, we are. Yes, you do have a homework, but there's going to be more homework. Good. So it's really great. There's going to be more homework because we do need to still complete what we're doing. And learning how to do a proper lab report is an important skill you guys are learning in my class. Okay, so in our class, we collected data on the density of aluminum. And just a reminder about that. And I'm just going to start with segment 3. And segment 3 was that you guys measured the volume of your different blocks. Like that. And that's okay, Charlotte. You don't, well, yine. So just pay attention, Charlotte, and figure out how to do this, and you can get your stuff later and how to do it. I'm just talking through it. And you can always go back to the video also in terms of viewing it again if you're confused about something. So we measured the volume and mass for the 4 blocks that you had. And for the size of the blocks and the mass of the blocks, I think we ended up being up to about 200 cubic centimeters. And then over here, we ended up being just a little bit smaller than 600 grams, something like this. Okay, and we had our data, and our data looked something, I don't know, maybe not that steep, so a little less steep. So there we go, something like that. Okay, so we have data that looked something like that. And we did a straight line fit there. And we did last time talk about the idea of a proportional relationship. And you guys are talking about this in math as well right now. You should have, or you are, I'm not sure where you are in your curriculum, but I know, for example, my son Ben, he's in 7th C with Mr. Yakabuchi, and they're doing it right now. So I'm assuming that you guys are at a similar spot. Okay, so here's a straight line fit, and that's pretty good. And we said it's a pretty good line fit if the equal amount of points lay above and the equal amount of points lay below. It's kind of confusing. Okay, well, I'm hoping that rather than intensify your confusion, this physics application of proportional relationships will actually help you understand the math. Okay, so don't panic and let's try to figure it out. What is this relationship saying? It's saying that if we have more volume, there's more mass. That makes sense. Every time you have an increase in the amount of volume of aluminum that you have, the mass increases and increases proportionally, meaning in the same ratio. So if you increase the volume by a factor of 2, then your mass should increase by a factor of 2. That makes sense. If you increase the volume by a factor of 5, then your mass should increase by a factor of 5. Okay? So in this case, we can express this relationship through an equation. Now, in your math class, you guys use over here, you tend to use over here y. Okay, and I will always call this the y-axis because your math teachers tend to want to use y there. And they tend to want to use x here, and I will call this the x-axis. This is not really the x-axis. It is the volume axis or v-axis. And up here, this is not the y-axis, it's the y-axis. Okay, and mass axis or m-axis. So in math, you write a relationship like this. You say y. They don't use the quotation marks because they're just saying it's just the y variable, but it's not always in that direction, the y variable. In this case, for example, it's mass. So y is equal to some constant times x. Sure, yeah. So the proportionality constant or slope, those are the same things. We sometimes abbreviate it A or C or M. Here, I will use the letter A. Okay, and just to explain, another word for A is the proportional, oh my goodness, constant, or we also call it the slope. And we will learn more about slope later. Oh, you use K. Liz says you use K in your math class. Is that correct? Correct? K? K? Yeah, okay, good. So we're going to take this and replace it with K. Remind me who your math instructor is, just so I can kind of just know. Okay, good. So we're going to use K there, and that's going to be the proportionality constant, or the proportionality constante. Yakabuchi. Okay. Okay, good. So, good, thank you. So y equals k times x. And for our situation, though, we don't have y, right? What is our y? I think Zoom is another option that might not be super constructive, but I can look into it. Okay, so Thank you for the suggestion, though. Okay, so let's write down what the y variable is. The y variable is m. And I'm going to put a little arrow there because in our equation, m serves the same purpose as y. And we also have an x variable, and that's v. X is v. And there is also proportionality constant. And this proportionality constant is rho, like row, row, row your boat. So rho is density. We talked about density, okay? Density being mass divided by volume. Okay, good. So m is rho times v. The proportionality constant is rho. And the question is, how do we find rho? How do we find the proportionality constant? I will tell you. Look at a point on the line and pick one far over here that is preferably on a dotted line. You did your graph on Kästchenpapier, right? Good. Try to find a place where this maybe is right on an intersection like that, where this is 600 and this is maybe 225. Just say, okay? Okay, so here we go, 225. Okay, and this is 600. So the proportionality constant will be this value divided by this value. So K, in our case, is 600 grams divided by 225 cubic centimeters, grams. Okay, and we can use our calculator to actually figure that out. It could be about 3. Maybe for Ari's graph, that's the case. For us here, it's the way I wrote it down, at least, it's a little bit different. So 600 divided by 225, and I get out 2.67. Now, a couple things. Do report a couple digits here, but not 1,000. So 2.7, that's okay. 2.67, that's okay. 2.6666666666666666666667. Too many. Don't do that. Okay. So also, that's the first note. The second note is do report the units. It's grams on top and centimeters cubed on the bottom. Grams per centimeters cubed. Okay, that's our value that we found based on my data on this graph. When you do this with your data, your number will probably be a little different. Don't just report my data, report your own data. I mean, my data is kind of made up anyway, right? I didn't actually measure this. I just wrote it on the board. Okay, reminder, use a point on your line. Do not use a data point. Use a point on your line and then take the y value divided by the x value. Yes, there will be an assignment on this to turn in your lab report. Correct, Savoy. Okay, now, once we're at that point, now we can compare the number that we found. This is our found density. So this is rho measured. And we can compare that with the accepted or the professional value, rho accepted. Okay? Okay, so rho accepted is 2.7 grams per cubic centimeter. Okay, so when you report your result, 2.67, I want you to compare it to the theoretical or accepted value and make a statement about whether that's close or not. We will not calculate percent error because I think it's a little, yes, that's intentional. That better? So, better? Okay, it's too low. I think it's okay now. So report your value, 2.67 or whatever your number is, compare it to this, and just say, if you want to calculate percent difference, that's cool, but we're not going to do that in this class yet because I think it's something you guys are still learning. But otherwise, just say, that's really close. It should be pretty close. Or say, well, I think it should be closer. Something like that. That is going to be your conclusion. In your conclusion, that's part 4. Reminder, this was part 3. The part 3 is the conclusion analysis section. Okay, you're going to state what you found. Okay, and specifically, what did you find? Okay, you found that M is equal to rho times V is confirmed. This is a relationship that's true in physics, that mass is density times volume. But you found that to be true because you found this to be a straight line. So you'd say mass equals density times volume has been confirmed because our data is a straight line. Now, the other thing you should do is state what density for aluminum you've measured. At that point, mention your value, okay, your value for the density, and compare to accepted value. And then you're done. Whoops, are we done? There we go. And then compare to the accepted value, and then we're at the end. Okay, so if you don't, so that's it for the report. And there are 4 sections again: setup, table of data, graph, conclusion analysis. We've talked about all of them very carefully. If you don't remember parts, then talk to somebody, took a picture. I think Savoy took a picture and put it in the class chat, for example. And this obviously should help you through parts 3 and 4. I will make a deadline for when to do this, okay, and turn it in. The assignment on Google Classroom will continue to be happening. There will be continue to come assignments as well. And we will also move forward in terms of maybe doing some more chalk talks like this with the whiteboard. But trying to figure things out. So let's just leave it at this. Every live stream I will post. I will now get on Google Classroom and post you guys an actual assignment for this density lab, and then we'll figure out our next steps. Okay? So I will okay. 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 If there are people who don't have access to the class chat, it would be helpful to have access to those files. Maybe Savoy could post them into the Google Classroom chat, okay? And otherwise, I can look through. Savoy, could you maybe do that? Post the files on Google Classroom. I believe you can comment on the class and then just post as an attachment. Thank you, Savoy. And if you're missing any, I can look if I have the files. But otherwise, it would be good to have those on there. Okay, good. I think, yes, all the lessons. That'd be great. Good. thank you so much for paying attention. You're off into your weekend. This is a real thing. Chalkboard pictures of the past lessons. Correct, Savoy. So this is, actually a weekend. So now officially you're not in school, I guess. But as you know, even during the regular school year, if you have some work to do, you might do that over the weekend. But otherwise, try to chill and relax at home. Don't go out. Don't hang out with friends outdoors. Don't go to the park unless you're just going for a jog. Keep your distance. You know all the rules in terms of making sure we can slow this thing down. Okay? All right, good. I'll end this 5 minutes early and have a nice weekend and talk to you soon, guys. Wait, I'm waiting. Can you show us your cat? Benjamin! We need my cat. Cat! Get the cat. Who's got the cat? 7F wants to see the cat. Quickly! Benjamin! Cat, 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 cat. Ben's got the cat. Here he comes. There we go. There's my baby. Here you go. Isn't he the best? Hey, he's my kid. Get away. He's very cute.
My cat.
He's my cat. He's my cat. Thank you.
Okay.
Should I do the cat hat?
Yeah, fine. Oh my god.
Cat hat.
Stop!
Cat hat. Cat hat is the best.
Hat ever lost.
All right. Bye. Have a good weekend, guys.